a speck of dust no heavier than a grain of sand, drifting through the vacuum near Jupiter's orbit. That's a micrometeoroid, and by itself, it means nothing. But scale it up, and you get something the human mind was never built to hold. Somewhere out past the edge of everything you can see, there are objects so violent, so extreme, that the laws of physics themselves start to bend around them. This is a countdown through the most unstable things the universe has ever produced, and the first one barely counts as dangerous at all. That's the point. It's where the ladder begins. Rogue planets, new star, no orbit, no light source of their own. These are worlds that were ejected from their solar systems, flung into the dark by gravitational chaos, and left to drift alone forever. Take a planet the size of Earth and strip away its sun, and you get a world locked in permanent, absolute night. Estimates suggest there could be billions of them wandering our galaxy alone, untethered, invisible, unless you happen to look at exactly the right angle at exactly the right time. Cold enough to freeze an atmosphere solid, silent enough that nothing would ever announce its approach. But a lightless world drifting in silence is nothing compared to what happens when a star starts eating its own neighbors. Because the next entry doesn't wander quietly, it feeds. Red giants are stars nearing the end of their life, swelling outward as their cores run out of fuel to burn. When our own sun becomes one in roughly 5 billion years, it will expand outward and may reach as far as Earth's current orbit. Picture a star so bloated it could swallow entire planets whole, engulfing them layer by layer as its outer atmosphere expands past where they used to circle safely. It's not fast. It's not explosive. It's patient, and that patience is what makes it worse, because you cannot outrun something that simply grows until it reaches you. But if a red giant is a slow devouring, the next one on this list is exactly the opposite. Neutron stars are what's left after a massive star collapses in on itself, and the result is one of the densest objects known to exist. A teaspoon of neutron star material would weigh about 1 billion tons here on Earth. That's the mass of a mountain compressed into something you could hold in your hand. Some of them spin, some of them emit beams of radiation like a cosmic lighthouse, and the fastest known ones rotate hundreds of times per second. A crushed sun, spinning faster than a kitchen blender, throwing radiation into space in every direction. And that's before you learn what happens when one of them decides to erupt. Magnetars take that same crushed core and give it a magnetic field trillions of times stronger than Earth's. The magnetic field of a magnetar is so intense it could theoretically distort atoms from thousands of miles away, stripping electrons out of their orbits before you ever got close enough to see it clearly. In 2004, a magnetar released a burst of energy so powerful it briefly affected Earth's upper atmosphere from across the galaxy. Not visible light, not a shockwave you could feel, just an invisible pulse of energy crossing tens of thousands of light years and still leaving a measurable mark. If you've made it this far into the universe's most extreme objects, drop a like right now, because the next entry doesn't just distort atoms. It erases the difference between matter and light. Because after magnetism comes the thing magnetism was hiding from you the whole time. Black holes are regions where gravity has become so strong that not even light can escape. We have never directly seen the inside of one, and we never will, because no signal can travel back out once it crosses the boundary called the event horizon. In 2019, astronomers captured the first ever image of a black hole's shadow, and in 2022, they imaged the one at the center of our own galaxy. That one is called Sagittarius A star, and despite holding roughly 4 million times the mass of our Sun, it's so compact from our distance that imaging it was compared to photographing a tennis ball sitting on the surface of the moon, a gravitational well so deep that time itself slows down near its edge. But even something that swallows light is not the most unpredictable thing on this list, because at least a black hole stays where you expect it. The next entry doesn't. Rogue black holes are ones that have been flung out of their host galaxies or drifted away from any visible companion, and they carry no light, no glow, no signature to warn you they're there. Astronomers have found candidates for these using gravitational lensing, watching the light of background stars bend as an invisible mass passes in front of them. It could pass through parts of our galaxy, and the only evidence would be a brief flicker in starlight millions of years apart. No warning, no approach, just a gravitational shadow slipping through the dark, and you would have no way of knowing until the light behind it already told you it was too late to look away in time. So what happens when gravity like that becomes unavoidable, sitting not at the edge of the galaxy, but at its very heart? Every large galaxy, including our own, appears to have a supermassive black hole anchoring its center, and the galaxy's stars orbit it the way planets orbit a sun. Our sun takes roughly 230 million years to complete a single orbit around the center of the Milky Way, meaning it has only circled a few dozen times since the solar system formed. Picture something so massive it doesn't just bend light. It organizes hundreds of billions of stars into a slow, silent orbit spanning hundreds of millions of years per revolution. A gravitational anchor so old and so still that astronomers have described it like a lion sleeping at the center of the galaxy, quiet for now, but never actually harmless. And even that lion is a kitten compared to what's coming next. TON 618 is one of the largest black holes ever identified, with an estimated mass tens of billions of times that of our Sun. To put that in perspective, its size alone is large enough that it could engulf our entire solar system, out past the orbit of Pluto, without even reaching what would be considered its true edge. It sits billions of light years away, a scale so large that comparing it to anything familiar starts to lose meaning entirely. But raw size isn't the only way an object can break the rules of physics. Sometimes it's not about how big something is. It's about what happens the instant it explodes. Gamma-ray bursts are the most energetic explosions known to occur in the universe, believed to be produced by the collapse of massive stars or the collision of neutron stars. A single gamma-ray burst can release more energy in a matter of seconds than our Sun will produce over its entire multi-billion-year lifetime. If a burst like this occurred close enough to Earth and pointed directly at us, it could theoretically damage the planet's protective atmosphere from an enormous distance away. It's not a slow process. It's not a gradual buildup. It's an instant, directional pulse of destructive energy that crosses unimaginable distances in the time it takes you to finish this sentence. And this is where things become strange, because the next entry isn't a single event. It's a permanent feature of reality that most physicists believe should not even exist yet. Vacuum decay is a theoretical concept suggesting the universe's vacuum may not be in its most stable possible state. Some physicists propose that a small region could theoretically shift into a lower energy state, and if that were to happen, the new state would expand outward at the speed of light, changing the fundamental laws of physics in its path. Nothing could outrun it, and nothing could warn you it was coming, because information cannot travel faster than the boundary itself. It's not confirmed to be happening. It may never happen at all. But the mere fact that our equations allow for it, that the universe might contain a hidden flaw baked into its foundation, is enough to make physicists take it seriously. And if reality itself can be unstable, what does that mean for the thing that holds reality together in the first place? That brings us to the final entry, and it isn't a place. It's a question. Dark energy is the name given to whatever is causing the expansion of the universe to accelerate. And despite making up roughly 68% of all the energy in the observable universe, nobody knows what it actually is. We can measure its effects with extraordinary precision. We can chart exactly how fast galaxies are pulling away from each other. But the underlying cause remains one of the largest unanswered questions in all of physics, a kind of hidden ingredient the equations seem to require in order for reality itself to function the way it does. Every object on this list, the rogue planets, the magnetars, the black holes swallowing solar systems whole, all of it exists inside a universe being pushed apart by a force we still can't name. Nobody knows what it truly is, and right now, nobody ever might. If you made it this far, through crushed stars, and invisible black holes, and a vacuum that might not even be stable, you've earned a moment to breathe. The universe is not gentle, but understanding it is one of the few ways to feel less small inside it. If you're not ready to go back to normal space just yet, there's a full playlist waiting, exploring the strangest, most extreme objects the cosmos has ever produced. Subscribe before the universe decides to test any of this for real. Drop a like if you're still here, and we'll see you in the next one.